Hi folks, welcome back. In many recent videos and writing, I've been talking about this whole notion of a specialized harness, and maybe it's getting a bit abstract. So in this video, I want to take a look at a very specific, hopefully relatable example, something that I've been doing daily, and I'll walk through this example to show what this agent or harness looked like before and then what a quote unquote compiled version of it looks like. So the example I'm working with is a skill that I use daily in my agent setup. I use Codex, but it's the same with any harness you might use. And the skill is very simple. It does some content generation for me. So what it does is looks at my back catalog. I have a whole lot of blog posts and videos and stuff like that that I've put out, and it tries to select something out of that back catalog to post on LinkedIn. So this is the flow it follows. So it looks at all the stuff I've written or posted before. It checks which ones have been posted about recently, picks a good candidate, and then writes a draft of a short LinkedIn post with a link to this original blog post or essay. And it doesn't post it right away. I don't just post anything that this comes up with. Often I won't even post the draft, but I'll use the draft as a starting point and very often rewrite it in my own voice the way I would have. But this is a useful nudge for me to look at my old stuff and see what I can post on LinkedIn. And all these steps are written up as a skill. So I have an automation that fires off daily that invokes the skill, and it has a bunch of drafts waiting for me to look at. And this is a skill that I want to compile into a specialized harness. So before I get into how I did that and what the difference is, how it looks, I want to highlight the big wins you get out of doing this. So first of all, you use way fewer tokens. In this case, 94% fewer tokens. Almost all of them are cached. And of course, the reason that's happening is that you're making way fewer LLM calls. And so that also results in a huge latency improvement, almost a 90% drop in the time taken for this end-to-end workflow. The basic idea is that while the old system basically used the model or the harness, in this case the harness was Codex, it used Codex as a general purpose reasoning planning workflow engine. So all those steps that I described, which is like finding the content to look at, selecting one. So all that stuff, it has to plan for, it has to maintain state about, it has to call tools. All that is being reasoned and planned and tool called by Codex. Whereas when you compile this into a specialized harness, you'll see that a lot of the steps get simplified into purely deterministic code. And only a couple of steps, these bright orange ones, call out to an LLM. So the step of finding all my old content, that can just be straight deterministic code because it knows all the places, all the URLs and websites I write at. It has access to that content. It doesn't need an LLM call to reach all that content. Then looking at various filters, things like which ones have I plugged recently and so on. Again, all that doesn't need an LLM. You can just look at recent posts. The two steps that need an LLM call are selecting a good candidate because that has some natural language and language understanding criteria. And of course, the generation of the draft content itself. It's really helpful to look at the old and new skills side by side. So here I have the old skill on the left and the new quote unquote compiled harness on the right. The new skill, such as it is basically a very thin bootloader because all it does is say, call this Python file. So the new workflow is driven by this Python code and not Codex. And as you can see in the old skill, everything is natlang. So how you go and find sources, which sources you look at, all that is natural language. The deduplication and selection rules are also natural language. So in the old skill, everything is specified as natural language. And in this new specialized compiled harness, like I said, it's driven not by the model, but it's driven by code. And the code knows how to go and fetch all these previous articles I've written. And it can compile an inventory of all that stuff. And then here again in orange, you can see where it's calling out to Codex to actually do work that requires an LLM. So one of them is to select a good candidate, and another one is over here to draft a post. And everything else is just purely deterministic code. So how did I get to this new specialized harness, this compiled harness? I basically used a one-time compilation pass, like I've been talking about in previous videos. I looked at all the historical traces I have from running this skill in the past. And then I used a powerful model. In this case, I used Soul now that it's out. It's pretty good, by the way, to examine all those historical traces. And I prompted it to look at which ones really needed LLM calls, which ones could be code. I gave it all the knowledge I had about compiling harnesses and building specialized harnesses in the form of all the writing and Git repos that I've built around this idea. So I gave it all that stuff. I told it to go look at previous historical traces of my LinkedIn draft skill, and I told it to make a new specialized harness for it. And that's what I just showed you. Yeah, and as expected, the output is about the same quality. It's exactly the same quality because I'm not even using a cheaper, lighter model. I'm using the same model for generation and selection. So those two places that had LLM calls. But the thing is, I'm just making so many fewer LLM calls with the specialized harness that you get these huge wins. 94% reduction in tokens used, 87% reduction in latency. And obviously that directly translates to cost as well. So hopefully that makes the idea of a specialized harness a bit more concrete and relatable. I'll link to some of the other stuff I've written about it in the description of the video. Thanks. I'll see you in the next one.